Second part of my presentation, what we might do together. Probably more interesting. First, visualization is everywhere in design science. And I've noted during the previous talk the kind of charts that you have shown. We have seen pie charts, catalogs, color tables, timelines, radar views, dendrograms, tree views, bubble charts. What does it mean? That it's extremely difficult to understand things that cannot be visually represented. It's the way the brain works. Another thing that is important to know is that we don't see with our eyes, but with our brain. And it's a major difference. Why does it mean? It means that, for instance, there are some experiments that show that you can show to people exactly the same graphics, a bar chart, a very simple bar chart. If on a situation A, people say, okay, the left bar is smaller than the right one, and most of the people in the room are saying, okay, it's true. And in another, in a B context, people are deliberately lying. The subject, or the given proportion of the subject, lies too. So he sees that the bar is shorter, but he will say that it is larger. It's clearly a social effect for a very simple visualization. Another thing is that we knew very few about how people understand graphics. We really knew very few. And we have some ideas about, I would say, visual perception, which is basically cognitive psychology. But as soon as we are going to real graphics, combining colors, shapes, interactivity, and business knowledge and so on, we knew nearly nothing from a scientific point of view. Okay. So, what can visualization science bring to design science, and what can design science bring to visualization science, which is also perhaps the most important question for this workshop. Visualization science can help to support the design process. It can also be useful for analyzing or studying a design process. So, in this case, the visualization, the graphics, what you can visually see, helps to understand how the people who are designing something work. You draw graphics, you draw sketches, and it helps you to understand the process. Of course, if you had better graphics, if you had more powerful graphics, more interactive graphics, probably you could better understand the process. What can design science bring to visualization science? And we have also experienced this. Design science, or designing visualization artifacts, is also a good use case for design science. Because usually, when I'm talking with people who want to come to have new visualization tools, I used to say, don't think about graphics. First, think about your problem. First, think about what you have as data. Think about the question that you have to solve, and at the end of the day, we will probably try to find graphics, an appropriate graphics. It also means that you first have to specify your problems in general terms. For instance, I have to see a time series. Okay. What do you want to do with your time series? I want to see the trend in the time series. Okay, it's a general issue. Next method, is your time series multivariate or not? Yes. Are there numerical, categorical data, and so on, and so on, and so on. And at the end, you say, okay, perhaps this generic graphic can be used for you, and next you, of course, you contextualize the graphic to the special need. Okay. Another important thing is that we do need prototyping, because it's impossible for people to understand what a new graphic is if he doesn't see this. I can explain to you, I have tested with people, external people of the team, say, okay, we have designed a new graphic that do this. People don't understand. You try to describe what are the visual parts, what are the meanings of the graphic they don't understand. You show it, they try to understand it. If it's embedded in a tool, okay, say, okay, it can be useful for this. So this is really required to have a good feedback and to be able to re-instantiate iteratively the process. So it's really design-based. So, in the first case, to summarize my talk, visualization can be seen as a tool. So, the purpose is supporting design process and visualization is simply a tool. Or, design science is a tool. And the purpose is to have new visualization and use design science methods. There are two possibilities to make links between the two disciplines. Some examples. If you have to visualize a product or a service to be designed, in engineering school, I have a background in engineering, so in engineering tools, of course, we have some representation of the geometry. For instance, in mechanical engineering, you can see an engine, the CAD systems, but you also have representation of the functions, which are abstract concepts. And in most of the cases, you have graphics showing the behavior, the structural components, and whatever. So visualization is clearly used in the design services or products. In this case, it supports the design process. Second case, you want to study what some of the people here do. You want to study, to investigate, to better understand the design process of many instances of the design process. And for instance, you do field studies and you try to represent actors, artifacts, relationships by graphics. And another possibility is that you have done some field research, you have theory, and you want to communicate this theory. So you build or you define a reference process. And to communicate, or for education purposes, you want to make your design reference process understood by the people, you draw graphics. In other cases, you may also want to monitor, to control design processes. In the same way, you can also have visual tools to control, for instance, if you have some stage gate approach, with decision to be made at a given point, depending on what you have or what has been achieved so far, you can also have some visual tools to help you to understand where you are in the process. So visualization to study, control, communicate about the design process. So, other point, design science for visualization artifacts. As I've said before, our experience is that to design successful tools, we need iterative design, we need prototypes, we need feedback from the field, feedback from the users, to test real cases, real data, real users, real problems, and then from this problem abstract some conceptual problems. Let's take an example. You are asked to represent the contribution of several business units to the benefits of a company. Okay, you can say, I will use a pie chart. Good point. What do you do if one of the business units make losses? Problem. You cannot represent negative value in pie chart. Okay. Doesn't matter, I will take a bar chart. Okay. In a bar chart, you can represent positive and negative value. Good, but in a bar chart, you cannot understand the proportion of the contribution of each business unit to the whole, because the cognitive process is too complex. So, even for an example as simple as this, we do not have graphics that can simultaneously represent the contribution of one subsystem to the whole systems with the possibility to have a negative contribution. We don't have it. If you solve this problem, and if you get a license for this, you probably will be rich. Because there are millions, billions of applications of these kind of things. Simply to let you know that behind graphics that everybody draws every day. There are also some theories, there are also some science, there are also some conceptual issues that may be solved. Some of the issues depends on the data structure, depends on the type of values, depends on another typical problem is that multi-scale data sets. If you have a data set with very small value, extremely large value, and middle value, and you want to represent it, for instance, on a scatter plot, it's impossible because, or you must use advanced scatter plots. In classic scatter plot, it's either you choose a very large scale and you hidden something, or a very small scale and you lose the context. So, this design research orientation has been used in one of the tools that we have produced, it's still evolving now, it's called Karuna. It's a visualization software, and we are working on this software for, I think, 6 or 7 years now. There have been numerous releases simply to capitalize on what we learn from the field, what we learn from the science, and progressively, iteratively, we found new type of graphics with application in the field, or new type of business application, because we understand that, we have solved this problem in one field, and this may be useful in another field, which is very common in this case. But in order to have such kind of results, you must go to the conceptualization of the problem. You must decontextualize what you propose for solving a given problem. So design science methods can clearly improve how visualization tools are produced now. So visualization are used everywhere in the design process. Design process is critical to deliver adequate visualization artifacts. So it's clear that there is a real potential for cooperation. It's for me obvious. And I think it's more or less what I. Thank you for your attention.